Welcome to another tutorial session. Today I want to talk about y is equal to 2 to the x and see what we can learn from this. This is a function, right? And it's 2 to the x is an exponential function. So let's take a look at this. If we want to take the derivative of this, obviously we don't have a obvious rule that we develop for these kind of exponential function. However, what we can do is we can rewrite this as remember what we said in the previous episodes using ln on both ln technique. We can ln on both sides of this equation. So ln 2 to the x, right? We can do that. And then we can decide to manipulate this problem and then differentiate this a little bit. The first thing first we always need to look at is when we have an ln of something with an exponent, this exponent can be brought to the front. So we will rewrite this again. So this is ln y is equal to x times ln 2. Now ln 2 is just a number. This is a constant. This is a constant. This is a number. It is also almost like if you have x times 4, which can be written as 4x, right? So x times ln 2 can be just ln 2 times x. So the derivative of the 4x will be 4. The derivative of ln 2x will be ln 2. So let's take a look at this. If I take the derivative implicitly, I have 1 over y dy. Derivative of x times ln 2, which is the derivative of ln 2x, is just ln 2 times dx. I want to make sure that you pause a little bit, make sure you really understand what I just did, okay? Because this is ln 2, not an ln x. So ln 2 is a number times an x. When you take the derivative with the power of 1, is you just end up with that number. The same way we will look at x times 4 equal to 4x. If I take derivative of 4x, the derivative of 4x is 4, right? Does that make sense? Okay, now so we have 1 over y dy is equal to ln 2 times dx. Then dy dx is equal to ln 2 times y. Dy dx is ln 2 times, and y is previously defined as 2 to the x. So what can we learn from this? What we can learn from this is that if I have y is equal to a b to the x, b simply means any value base b, a number to the power of x variable, then the derivative of y prime is ln b times b to the x. This is the shortcut that we can use for other problems similar to this. So an example, find y prime, right, d dx of say 23x. Well, that's just ln 23 times 23 to the power x. Okay, that's that simple. Okay, now doing the same thing similarly, if I was to say I want to take the integral of 2 to the x dx. Here's what I want to do to manipulate. I don't have a specific formula at the moment, right? The point is doing something like this to see if we can come up with a shortcut like this, which later on to apply to some other problems. So we start with a simple problem like this. What we can do is we can manipulate this to some form of function of e. So we can say if 2 to the x can be written as e to the ln 2 to the x, right? This is something we learned before. e to the ln of something is just that something. Okay, so we can do that. So we can actually rewrite this as e to the ln 2x dx. Now, why is this important? Let me just show you in a bit. What I can do is then I can take this x and then put it in the front again. Very similar to right here. So I will take this. I have integral e to the x times ln 2 dx. Now remember, x times ln 2 is a number. So I can also rewrite this as ln 2 times x, right? So in this case, what I can do is use substitution. Say u equal to x times ln 2, or u equal to ln 2 times x. Just another way of writing it. I just want to make sure you're clear. This is u substitution. The question is, why do I do that? I do that because I recognize that integral of e to the something, right? Integral, I also remember in this case, integral e to the u du is e to the u plus c, right? So I want to take advantage of this. So that's why I set this as u, because I am hoping that this whole thing becomes e to the u, okay? But I still need to replace the dx, so I need to make sure that I will do the due diligence here. This is ln 2 dx, so dx is equal to du over ln 2. So we write this further, e to the u, right? E, u substitution, turn this whole thing into u, dx, make that into du over ln 2. That just means 1 over ln 2 integral e to the u du. So that is easy. That's 1 over ln 2 times e to the u. Now I'm ready to rewrite this back into the original form. So write it into original form, equal to 1 over ln 2, e to the u, e to the x ln 2 plus c. But e to the x ln 2 can be simplified. I end up with 1 over ln 2 e to the ln 2 to the x plus c. Now remember, e to the power of ln of something, it's just that something. So this is 1 over ln 2 to the x plus c. So we went from integral of 2 to the x dx to 1 over ln 2 times 2 to the x plus c. This shows me that we can do a few things, right? This gives me a shortcut. The shortcut is that if I have integral of b to the u du, it will be 1 over ln b times b to the u plus c. This is my second shortcut. So same function, taking the derivative, I get this. I use this function, this problem, to illustrate a shortcut. I have the same function, I take the integral of this, I end up with this, and then I end up with a shortcut for something like that. See you next time.